Okay, so the next question is we're tasked to compute the maximum shearing stress developed in the fiber at 1 meter from the left support. So where manadapita 1 meter from the left support. So by simply looking at the figure from the left support and you measure 1 meter. So from here, padung diri, this is the 1 meter. Kanadara dapuita. So if that's the case, then all we have to do is project it downward kung unsa nga shear value ang naigo. So ang naigo nga shear value is 50. Therefore, this is the shear that we will be using at 1 meter. Okay, so nanatay shear force. So same gihapon atong buhaton. I'll just name this one as letter A. Letter A answer. Okay. Then for letter B, we have to find for the maximum shearing stress, but it's at 1 meter. At 1 meter from the left support. So I'll have V at 1 meter times Q I over B. So which is just the same. The same ra sa atong gibuhat kanina. So we have to substitute everything. So ang values, instead of 550 for the shear, we will now be using the shear force as 50 newtons. That's according to here, that one. Because that lies at 1 meter from the left support. And then the Q would still be the same. Q is 7,812,500 mm cube divided by I na 2.6042 times 10 to the 9th power mm to the 4th times the same gihapon ang atong base, 250 mm. And we will obtain a lesser value, much lesser value because we are just only using 50. So the value here is 6. So that's 0.0006 MPa. Or if in kPa, you multiply na to 1,000, it's just 0.6 kPa. Or that's in kilopascal. So this is our answer. Okay, so here, this is our answer for the shear stress at 1 meter from the left support. Okay, next question. So I'll just name here, I'll just call this one as letter C. So our letter C, it says here that we're going to get the shearing stress at 40 mm of this point. So same gihapon nga point here. So same gihapon atong value, 50 newtons as the shear force, but ningon siya nga 40 millimeters from the top of the fiber. So asa man nadapita from the top of the fiber? Here. Let's just copy this one first. Create lang ito sang kapihon. Let's copy. here. And this one, copy. Then let's paste it here. Okay, and I'll just remove some of the figures here. Oops. So we have paste. Just transfer that one here. Okay, so what we're gonna do now is I'll just draw na lang with a new one. So I'll just draw a new one, and then okay, and then I'll just specify the neutral axis, of course. So maybe this is the location of the neutral axis. Is it even? Okay, atong balikan. Okay, this is the location of the neutral axis, and then ningon ang problem that we're going to get the shear stress. So ang buhato na to kay, let's draw first the shear stress diagram. So the diagram would be like this one. And like that. So as what I have said ganina, that you will obtain the maximum shear stress at the middle or at the neutral axis. Pero right now, we're tasked to find the shear stress from the top fiber, 40 millimeters. So, asa man dapita ang 40 millimeters? Remember that this height here, this is an amount equal to 1/2 of 500, which is 250. So, let's just estimate this one. Kung asa dapita si 40 millimeters. So maybe na si 40 millimeters here. Tarong sa natong draw. No, so maybe na si 40 millimeters diha. So I'll just drop down a line here representing that this is 40 millimeters. So with that, kaya ang atong gisgutan is this portion man, so meaning to say we're going to get the shear stress at that particular point here. We need this shear stress, and it's not maximum because it's only found 40 millimeters from the top fiber. This one here is the maximum, and it's obvious nga dili siya maximum tungod ani nga diagram here, right? So how do we solve this one? First is identify the force, or the formula. It should be VQ over IB. But what is our, remember that we have the V already because we're tasked to find the same the stress at the same point. So meaning same shear gihapon atong gamiton. So I'll have here, and that's 50 newtons. And by the way, our I would still be the same, 2.60404042. times 10 to the 9th power millimeters to the 4th power. And then we're going to decide what is the length or the measurement of our base. Of course, kung asa tanang ngita og stress mo to ang base. So since we're looking for the stress here at this fiber, so unsa may base ani, that is equal to 250. No? Kay mo man ang base nga atong naagian sa kanang fiber. So 250. Next, let's solve for the Q. Q is no longer the same because our area now changed. So, na-change ang atong area. So, mo ni ang atong area nga atong i-consider. Here. Let's draw the atong i-highlight ang area. So this is the area that we will be solving. Pila man ang area ani niya. So makita na nato that this is the area that we are looking for. So ang area is just equal to 250 as the base and the height is 40. Sakto? Yes, 40 millimeters iyang height. Diba? So that's 250 times 40. The area is 10,000. Alright, so we have now the area. Let us now solve for the barred y. What is the barred y equal to? Remember, the barred y's definition is the distance from the from the centroid of the area. Again, this is the area that we are considering, kani. So therefore, ang centroid aning area is found here. So nadira. And the definition is the barred y is the distance from the centroid of the area padung sa neutral axis. So do not forget that. Mao ni ang definition sa barred y. So pila may distance ana? It's going to be no, unsa man ang distance. So of course, we will be using 250 and we're gonna subtract this distance. Pila man nga distance. So kani nga distance, this is just 1/2 of 40. No? So 250 minus 1/2 of 40. Mo na ang barred y. Okay, so that's 250. Ayan na lang. So that's 250 minus 1/2 of 40. And that is equal to 230. So since na naman tayo mga values for V, Q, I, and B, wala pa tayo Q. Let's solve for Q first. Somehow, it's just the product of 10,000 times 230. So, the answer is 2,300,000. So, that's 2,300,000 mm to the 4th. And let us proceed in getting the shear stress. So same gihapon na tong V, that is 50 newtons times the Q is 2,300 mm to the 3rd over I, the same gihapon na tong I. So that's 2.6042 times 10 to the 9th power mm to the 4th power times the base of 250 millimeters. So ang answer na to gihapon ani is megapascal. So 50 times 2.3 to the 6th over 2.6042 exponent to the 9th times 250. So it's going to be, the shear stress is at 0.000177, and this is in megapascal, or in kPa. All we have to do is multiply it with 1000, so that's 0.1766 kPa, or kilo pascal. And this is our answer. So let me just finalize this one. And here, this is our answer. And this ends our first example for horizontal shear. Let's continue